Hello, guys. Good afternoon, good evening. Welcome back to a new educative session in physics. Now, we previously had notes on heat, the different forms of heat transfer. Okay, the different heat transfer was when introducing what heat is actually is. So we had heat capacity and specific capacity in our previous lectures note. Now we are going to discuss about what heat transfer is really, what heat transfer is exactly. So now we had heat transfer as definition to start with, or to boom the explanation of heat transfer. We first of all have to put in the back of our mind that heat transfer is based on what? On the difference in what? In temperatures, that is from one area to another, or from one end of a material to another, or better still, from one end of a substance or an object to another end. That is, for an object to transfer heat, we need a concentration gradient, that is a heat gradient from high temperature to a low temperature. Okay, so now looking at definition or the introduction of heat transfer, it's simply the transfer of heat energy from a high temperature level to a low temperature level. Wow, that's so cool. So now we have the movement of heat along a material, mostly metals. Mostly metals, guys. We have mostly metals, which is in a solid. We have in a liquid, water, that is, or any other form of liquid, which we are going to expatiate, and in gases. Wow, that's it. I'm seeing so many people are so interested in this. So I am going to go immediately to the next session, the next part of this our beautiful lecture. So we are going to see the different forms of heat transfer. Now I was saying in the beginning that heat transfer is based on the molecule. Okay, we have heat transfer only occurs when we have different molecules changing or passing the energy in terms of juice, okay, in terms of juice, from one molecule to another. And this is thanks to the kinetic theory by Newton, the kinetic theory that states that we have matter, okay, or substances are made of very, very small particles which are always in constant motion. Okay, we have constant motion molecules that are always either vibrating, moving around, that is spreading or transferring heat energy from one molecule to another. And that is what happens when you have an object placed in a hot object, and then you realize that the end of it is actually getting warmer with time. That description is for the first type of heat transfer, which is by conduction. Now, conduction is a heat transfer mostly in solid, that occurs mostly in solid. Okay, we have, if you place an object, for example, those that are actually versed with cooking, okay, if you put your spoon in a pot, in a hot pot, you realize that at a particular time the end that you're holding actually gets warmer with time. If you're not careful, it may burn you. Now, the one end, only the tip, the other end of this object was inside the hot meal, for example, and eventually the other end is warmer. Now, this is simply because kinetic theory had explained everything for us. That is, molecule acquired heat from the heat substance or heat object or the heat meal that will actually move in collision with the other molecule, that is transferring heat, colliding with other molecules from one end to another. There is a kinetic theory. For those that are joining us now, we are on heat transfer, and we just explain what conduction is, the first type of heat transfer. Now the second type actually that occurs in liquid, mostly liquid, is the process of, we have convection, or you can say convection current. Okay, convection, which is a type of heat transfer that occurs only in solids. Okay, you actually observe what happens when you are cooking, or you put a pot of water, okay, on the fire. Okay, so you realize that at a particular moment you have bubbles that are being formed. You have bubbles that are being formed, and this bubble gets to the surface. Okay, it gets to the surface, always comes up to the surface, and then very soon at a particular high temperature we have condensation that occurs when the water drifts back into the pot. Now convection current is the type of heat transfer that occurs in liquid. Okay, now what makes the water to go up is simply because we have two factors, which is the density of the liquid and the temperature of the liquid. Okay, if you happen to take, let's take a pot of water. Okay, let's take a pot of water, and then you try to divide it into two in a horizontal pattern, half. Okay, halfway the pot. Now the fire or the heat supply from the bottom of this pot happen to warm the water. Okay, and then this water becomes warmer and eventually becomes less denser. Okay, it becomes warmer and less denser. Now the less dense liquid happens to move up the pot, while the one up that is actually cooler will move down. That is how convection current is actually created, when a substance have a difference in temperature, which affects the density of that liquid. So we have a continuation of warm and cold. From the bottom horizontal line that was drawn, we have warm and cold. So we have warm water that will move up and the cool water that will move down. Oh, that's so nice. That's so simple to understand. Now, then the last form or the last type of heat transfer is radiation. Okay, it simply describes the transfer of heat through space. Okay, the transfer of heat through space without any stress. We have the transfer of heat through space, and the energy is transferred in electromagnetic pattern. Okay, we have electromagnetic radiation that occurs here. Okay, it moves through space by the collision of molecule in an electromagnetic pattern. Okay, oh wow, that's so great. Thank you very much for watching. We get ready for the next episode of Learning Never Ends. This was Briskenla. Have a nice evening. Thanks.